welcome everyone. We will get in here, and thank you, Lori, for the swift introduction. We don't need to go through that. Today's agenda, we want to talk about the introduction to digital twins and some of our industry's challenges. We've all perhaps heard the term, but we want to, again, give a brief introduction to them. But really the meat and potatoes of today is to talk about digital twin execution plans, what kind of is the purpose of them, and then how do we develop them. And we'll talk about some of the real world examples and so on that we've dealt with. And again, as needed with time, we'll deal with some conclusion and wrap up at the end. All right, want to start off talking about digital twin. So what is digital twin? It just depends on who you ask, and it depends on your use cases. So it depends on if you're looking at the, for instance, the Digital Twin Consortium. If you're looking to talk to, or if you go to the Autodesk website, perhaps the Gartner website, and so on and so forth. There's a number of different definitions. There's a number of different concepts. As you can see here, the digital twin is a living and breathing and reporting data set. And so every one of these, most likely every one of these, something is going to fit your mold, your industry, and the work that you do, and your data that you're producing, your designs, your engineering, your architecture, etc. The data that you produce on any given day is going to become part of, ultimately, a digital twin. And this is just a very good representation of the broad nature of digital twins. On any given day, you are working in a digital twin. We might not think about it as a digital twin, but in reality, it is a digital representation of the physical and real world around us. Ultimately, bottom line, a digital twin is a virtual model of a physical object, but also importantly, the processes and the systems that are used to monitor and simulate how these things operate and behave in the real world. And so we might not be thinking about digital twins in our industry or our space because it might not be something that may have not occurred to us and how we fit into the digital twin world. Well, if we're talking, it doesn't matter where you are, in what space you're in, which your industry, there is a digital twin out there. Whether you're in the smart cities of the future, a connected campus of today, or potentially, your county's water treatment facility. To makers and manufacturers of all the products, the widgets, the cars, everything that we use in our everyday lives, the turbines, like a gas turbine on that we use in manufacturing facilities and on our jets and everything like that, all the way down to our DNA. We may not be thinking about it, but ultimately, all of the work that is done in our medical facilities creates this data stream, a digital twin of our bodies. And with that in mind, what are some of the key points and concepts about digital twins that can help us achieve these desirable outcomes? Well, if we think about it at a high level, assets. We want to understand how our assets are operating with streams of information that are reporting on dashboards, things like that. That kind of information is what's going to allow us to be proactive, and when there's milestones or events that are occurring, we want to be able to meet those events and be prepared for what may occur. we're able to track these perhaps anomalous behaviors and identify where there's something that may be off. We're using things like AI to identify these anomalous behaviors. All of that information, these streams of data, are what feed into our digital twin, and they are what allow us to achieve some of these desirable outcomes. We need greater access to, we need to better visualize the data that we are creating and make it more consumable. We need to have ways to measure and identify metrics that are important to us. All of that access, visualization, and metric and measurement of KPIs and so on is what allows us to get better and to improve. And as far as where all of this comes from to develop a digital twin, where are all of these data streams coming from? Well, no matter where they're coming from, they all collect and come together and can be a part of and live in a digital twin. And we have, through the Autodesk platform services, these different platforms where all this data is coming together and being able to synchronize and be able to talk to each other. Again, these different data streams, these are what are going to feed and provide us that rich information data set that ultimately makes a digital twin worth its investment. Here are a couple other examples. So in this slide here, this is, again, on this Autodesk Platform Services, our large model viewer. What we're seeing here, this is an industrial site where we have pressure vessels and valves and tanks, and we need to be able to come in here and parse the data. We need to be able to pull this apart, understand down to the granular levels of detail what is going on with a given system or a given piece of equipment, whatever the case may be. But we need to be able to pull this apart and understand it in that more granular level of detail. And we need to be able to track, visualize. Again, this is what we're seeing here, obviously the visualization. We need to be able to identify real-time data. This is what gives us that insight into how we can be more proactive, right? So the point of this is to understand that these digital twin, this capability is out there today, and it can be applicable to you no matter what industry you're in. Obviously, seeing this next example here is that, that turbine, that piece of equipment that we saw a moment ago. Again, it doesn't really, if you have that digital representation, you've designed it in no matter what software it is, you have a digital twin of some scope of a given project. And these tools out there that are, cloud-based, and they allow us this broader access to more stakeholders, things like that. They afford us the ability to be more proactive and really get ahead of the curve as far as innovation, maintenance, and just making sure that we are operating optimally. All right, so we've seen a little bit about what it is. We've all probably, again, heard about what that digital twin, but we hoped to help you understand maybe a little bit more about the broader nature of digital twins, and where it's not just in buildings, it's not necessarily just in infrastructure. It really can fit the mold of all of our industries. And with that in mind, what are some of our challenges? Let's take a deep, not a deep dive, just a cursory review of some of the challenges that we face. One of the things that some of the information that we've derived from this presentation was taken from the 2024 State of Design and Make report that Autodesk does. And by all means, if you get a chance, go check it out. It is an incredible report, very detailed report from industry leaders across the globe that gives us insight into what are they experiencing? What are some of their challenges? And what do they foresee? What do they foresee with industry trends? And where do they see things going? So it's a really, it's a useful data set for you to understand where others and other peers in your industries, where their heads are at right now. Couple of and this does come from that report, a valuable take, I thought, in this graph here. We understand, we can see where we were in 2023 versus where we are in 2024 regarding challenges, and what do these industry leaders see as changing over time? Well, as you can see here, it's intriguing where one topic or one concept is there in 23, but then it's not in 24. For instance, with number 3, the global economy and events, that's, you know, perhaps a remnant of 2020 and the leftovers of what we were dealing with there, and now we've potentially moved in to another direction as far as our challenges and where our concerns are. But two of the things I think that are most important is that really are what digital twins can have an impact on are perhaps cost controls, and perhaps 3, and data, and then innovation. So where can a digital twin play roles there? If we're able to be more prescriptive, proactive in the maintenance and in ensuring that we have the right data sets in front of us, we're able to automate tasks with AI and with overall digitization, things like that. These are innovations, and with these at the forefront of our mind as far as challenges we're looking to meet, a digital twin is going to help us to overcome some of those challenges and meet it with that digital footprint. Other challenges that we've all, no doubt we've all dealt with in our industries on any given day. The handover gap. This is where we are dealing with different authoring tools, different data, different information that may be from one end user to another. They are not necessarily able to consume this information. And it's somewhat, while we might get a cursory level of data or information, and it's just maybe flat 2D, it doesn't give us that additional metadata that would be helpful to us. There can be issues with that handover gap, and ensuring that information is actually accessible and consumable by all end users. That's certainly a challenge that we deal with today. And having a plan to perhaps align data streams and have information that can talk back and forth, that is definitely it's something that we want to overcome, and that we can with proper planning. All right, let's see, back up here. So a couple other things, connecting ecosystems. That falls in line with, again, connecting those data points, ensuring that the information can, from all these different disciplines, the end users, the softwares they use, whatever data they're collecting and handing over, we need to make sure that all those things can come together into that single source of truth. Whether it be a digital twin or data spreadsheets, whatever the case is, it needs to all come together and be interoperable. That's where that's another challenge we have to meet. Ultimately, something at the end of our projects, we need to ensure that we are handing over accurate information that is actionable, right? That information has to reflect the work that we've done up to date, so that moving into the next phase of information's life, a building's life, a product's life, it can be as maintained. That's ultimately the whole point, because we all understand that perhaps the largest expenditure in a given element, a building, a product, etc., is during its operation. So we want to ensure that that is efficient as possible. All right, moving into the purpose of digital twins and why do we want to get in there and potentially take a look at the value add for digital twins. Well, what can a digital twin deliver for us? Again, we've talked about being proactive and prescriptive. With the innovations that are going on today with AI and the Internet of Things and all of this information that is out there in the ether, if we're capturing that and we're able to monitor that information, it gives us this digitally accessible picture of what is going on at that moment. And we're able to, through these tools, these digital twin tools, it allows us to be, again, proactive, go out, investigate why something is, there's a potential problem, and ultimately put that plan together so that we can act, be proactive, fix things before they come to a head, problems before they come to a head, and be out there ahead of these issues. So digital twin execution planning, we have to start somewhere. We have to be able to achieve the end, right, end goals, but where are you? There's no doubt that everybody is in some phase of development and execution of a digital twin. It does not, it could be argued that working from pen and paper maybe not be the digital twin that you think it is, but ultimately we're working in software, we're working with computer programs, we're assembling these data sets, we are creating aspects of potential, pieces of what ultimately will accumulate or assemble to become a digital twin. So where are you in your digital twin maturity, right? So are you at that descriptive twin where it's essentially facilities data and you're able to, potentially you're working in the BIM world and you've got the low level, maybe not a robust comprehensive data set of all of the pieces and parts of that element. Moving on into an informative twin, that's again where this IoT, where we have reporting information being sent to a digital twin for us to observe. Moving into a predictive twin, that's where that analytical capability allows us to get ahead of the game and understand where issues may be occurring and perhaps mitigate risk so that we can ensure that something, a product line, pieces of equipment do not go down because we got out ahead of it. Ultimately getting to, and this is where these first three steps may be where most of us are, whether it be 1, 2, or 3. Ultimately, we're moving into the next few stages, 4 and 5. These are where we're headed. This is the goal, the target, but ultimately that comprehensive twin, that is where we're starting to have, where our digital twin becomes real time and a simulation so that we can perform what if scenarios and determine that, hey, this is if this, then that, and we can prescribe and iterate on our designs, on our facilities, on our products to achieve optimal operations and the best designs. Ultimately, the autonomous twin, we have to begin with the end in mind in order to achieve success, to achieve an autonomous twin, because we have to plan to get to this autonomous twin and ultimately that state where the facility, the manufacturing lines, they're operating themselves. We're there in some industries ahead of others, but ultimately we have to have the plan. So we begin with the end in mind to achieve that autonomous nature. And for those who have seen, we have Baymax here. He is essentially a very cuddly, cute way to look at the autonomous twin in the future for healthcare and so on and so forth. So the concept is there, and we're headed in that direction. It's just that we need planning. So with this slide, we understand everyone on the webinar can look at this slide and identify at least 5 things that they use in their daily business located here. And what we want to do is ask ourselves, are all of these items that you've picked, the ones that you use or potentially have on your radar that you're evaluating, are these things able to talk to each other? Are these things able to integrate? Can they talk to each other? Can I push information from one to the next? Will that information make sense? Are these formats able to be consumed? Things like that. So that's the question that we have to ask ourselves, because again, and even if you aren't utilizing some of these formats, we have to understand that our other project team members are using these formats. So how are we going to get all this information and these data streams to talk to each other? And this slide is just a fair representation of kind of the spaghetti of things that just aren't connected, they're not talking to each other, and then bringing them together with some analysis, evaluation of the necessary tools to make these things talk to each other and come together in order to create a more fluid data flow that is accessible and essentially is just a democratized data set that all can understand and consume. A couple more of these slides. I want to talk about the execution plan and kind of how it operates, what is out there today. So today we have all of our various personas, our owners, architects, engineers, those who are doing the installations, the fabricators, and then ultimately you see kind of the bookends. Owners have to come up with the capital, and then they have to operate. So they're on both ends. They're ultimately involved in both ends, but they're not granular. They're, so to speak, in the middle. We have our phases: the planning, design, manufacturing, construction, and then of course operations. And we have a little bit of overlap in each of these, right? So what we have today are plans for each of these phases and for these personas. They've all got their plan, and their plans certainly cross over from phases, but what do we have that actually connects the dots between these plans? Do we have a comprehensive document, a charter, something that is helping us to connect the dots between all these different, perhaps disparate languages and documents? That's where the digital twin execution plan comes in. Ultimately, with the proper planning and with putting in the time to achieve ultimately data that can populate a digital twin and is operable in operations, ultimately that can deliver us some of these desired outcomes. And you may not be that owner, but if you look at all these desirable outcomes, you no doubt play into some of these, whether you're in supply chain and logistics, whether you're dealing with sustainability and all of the impacts of who you affect and who, again, your vendors, your clients, your owners, everyone plays a role in one of these desirable stakeholder outcomes. So if we have a plan put in place to ensure that the information that we are planning, we're designing, we are building, and then operating together, if we have a plan for how our information is going to plug into that overall ecosystem, that is where we achieve more desirable outcomes for project teams generally. All right, I think we're going to hand over to Mark now.
All right, Alan, can you see my screen okay?
Good to go.
All right, thank you. So thank you, Alan, for that overview of digital twins and industry challenges and what a digital twin execution plan really means as a concept. So what we're going to take a look at here for the remainder of the webcast is how you go about developing a digital twin execution plan, some of the components that go into it. We'll get a little granular on some of the technology that's available today, but still keep it at high level enough where we're not digging too much in for the remainder of the time that we have left. At the end, we'll also go over a few case examples and as well. So first off, we're going to start here about looking at some overall processes and considerations when you are looking to develop your digital twin execution plan. Now, there's really three questions that start to come to mind as you start putting some pen to paper, so to speak, on this, or keystrokes to screen, depending on how you want to look at it. But essentially what it comes down to is, what data do we need? There's so many different data sources. Where do we start? Again, beginning with the end in mind, what data is going to be required for this digital twin execution plan and for our overall organizational charter? Also, how are we going to get all this data, right? There's so many different sources. How are we going to bring it together? What are our pathways and reasonings for connecting these things? What are the requirements and software that needs to work together, right? And lastly, how do we maintain it, right? So this really becomes a difference between, a descriptive twin and a predictive twin versus comprehensive twins, because if you're going to maintain data, you constantly need to update and refresh that data, make it sustainable to the overall process of a digital twin. You don't want it to be stale, right? So where are we going to get it? And how are we going to conglomerate and aggregate all this data? Oh, let me go back here. So essentially, Autodesk's platform services are a big key component of this, especially for us here at ImagineIt, right? This is something that has been rebranded in years, used to be called Forge when it was still in its infancy. But the platform services is a baseline cloud computing language and model that allows you to bring together data sources, right, that Alan alluded to earlier with the multiple connections. If we look at primarily Autodesk ecosystem first, right, there's an Autodesk data model that is shared between these with APIs. And essentially Autodesk has developed, for the better purpose of it, 3 different marketing buckets of Fusion, Forma, and Flow. But really they all play in the same sandbox. They're all part of the same data model and platform services, it's just different APIs. So we're going to take a look at design and CAD data, BIM data, manufacturing data, things of that nature. We'll get into that a little bit more in detail in a little bit. But also there's things to consider as well that aren't necessarily in the Autodesk umbrella, right? Maybe there are third-party CAD softwares, right? We need to consider that too. Maybe geospatial data, so GIS integration or InfraWorks models. Data visualization and 3D viewing, so bringing in sources which are not, traditionally viewable that you would see in your ecosystem. So making sure all that can be read in and visualized. We'll be looking at IoT and sensor data. So what does that mean for us? Basically a real-time sensor integration to keep feeding your digital twin. Time series data, so historical data from sensors or operations to track performance over time. Document and project management, so things like issue tracking and collaboration, tools for tracking assignments and collaboration within the platform. Linking in external databases like ERP and CRM systems. So customer relationship management as part of your digital twin, and basically allowing that knowledge to be externalized from your digital twin when things start to happen. Database integration as well, so linking in other SQL databases or cloud-based storages to Autodesk data, or perhaps automation and cloud-based workflows, cloud rendering or generative design. Custom applications and plugins such as writing custom algorithms for AI models or optimization tools, and other third-party applications. Collaborative tools and platforms such as Slack or Teams. Project management tools such as Trello or Jira. Or augmented reality, AR and VR. How do we integrate that into this entire digital twin? Other cloud storages, right? Things that are not necessarily Autodesk related. Data analytics and reporting, and we'll spend a bit of time on this one because simulation is ultimately really important to digital twins. But essentially bringing other data analytics in as well, such as business intelligence tools like Power BI and other custom reporting methods. But when we start, again, thinking about data we need, right, I think just from that last slide, you can understand that data collaboration has become more and more critical, more and more in-depth and complex, right? You need to really understand, again, the end in mind about what's happening. So structured planning, when you're putting together a digital twin execution plan, is really critical for any sort of success in this world. Identifying the data streams and the workflows across all these different disparate systems and how they need to play together, having that in your charter. Identifying dependencies around any sort of key element that we know is something we need to track, something that ultimately it's success because of this reason X, Y, or Z, and those foundational components that surround it. So again, we keep going back to it, but again, remember to begin with the end in mind. Identify those dependencies. So what we're going to take a look at next is some of these different data streams, right? How effectively these different types of data are designed to feed and nourish the digital twin, and how we need to get the data and how we need to maintain it. Okay, so let's start talking about CAD models and 3D models, right? If you're traditionally in a CAD software most of the day, this is where you perk up and say, yeah, I would like to know exactly what this affects with my CAD models and 3D models. But that's only a portion of what's important about data. What's really critical about your CAD models and 3D data is that they do provide that visual, right? When we saw the very first digital twin example in today's webcast, there wasn't showing every latch on a window, it wasn't showing every lug nut on a car tire, right? So there's an idea of a macro space claim for your CAD model and a micro, right? Depending on the level of a digital twin that you are scoping. Now, some aspects of that digital twin need to be readily available at the macro level. So if you were to click on a car, maybe it brings up a PDF or a spreadsheet of what the actual lug nuts are on that car and what the torque ratios are to actually torque those down correctly so your wheel doesn't fall off. Those are important things to understand about the scope of where the CAD model needs to take place. More often than not, fabrication usually just details the fabrication and never has a macro space claim, where they don't provide that or the information surrounding it. So specifications of blueprints, they're critical, making them accessible in the digital twin and making sure that that information is readily updated and fed to the digital twin is really important. Material properties, I say this more about, it's not just it's made out of steel or it's made out of lumber, right? This wood. It's also about what the metadata and classifications of things are, what the thermal conductivity of something might be, what the R value might be for something involving insulation. These are all critically important things that need to be passed through the digital twin. Now, you can do a lot of this work on the CAD model side of things. If you use the correct tool sets and the correct amount of data that you're putting into your digital twin execution plan or charter. Okay. Now, as we start to expand this more into a Internet of Things or a more of a predictive twin, essentially what's happening with things, sensor data becomes important, right? Like IoT. So bringing in data from different sources like Azure's IoT, Amazon's IoT, Google's IoT as well, different sensor data that might come in will provide some real-time updates, right? So what's great about that is if it's connected, it's always going to be nourishing and feeding that system. Whereas with CAD models or 3D models, you have to develop a way that those are constantly going to stay up to date. What a submittal might look like for a certain phase of the design, and what stage gates need to take place to make sure things constantly get updated. So for sensor data, also environmentally, what's important? So not just a sensor on a machine or a sensor in a room, but maybe things more external to that. Is there ambient heat or humidity in a certain area? What's that causing? What is that doing? Is that important to our digital twin, to our scope? Operational data, so performance metrics. So things such as, how quickly can we get, product from point A to point B? How quickly can we get shipping container from ship to dock? So things of that nature, capturing that information. Maybe that's done through database work, maybe that's done through simulation work, right? Machine operating states. So are your machines having a lot of uptime or downtime? Is there an average failure rate or maintenance records that need to take place in our simulations? Control system data, right? So PLC information and controllers or other automated systems. Also historical data. What's happened in the past? Descriptively, here's our maintenance records, here's our failure logs and our performance history on this machine. That ultimately needs to feed in somewhere into this analytic to make sure that your simulations are being done effectively. We start looking more at predictive data, so like machine learning models, using that past behavior to plan on what's going to happen in the future. There's products like Autodesk Fusion that do this already with toolware. And this is something that can apply to multiple aspects of a digital twin. Simulations, which I'll dig into here in just a little bit deeper, but that's basically data derived that might help predict what might happen under certain scenarios. Cost data, production schedules, supply and demand forecasts. These are all things will also assist very heavily in our simulations and the experiments that we do with our digital twin. Not just being informed about them, but also planning and monitoring what things will change if we toggle a lever or push a button that does something different to our digital twin. What's going to happen? Having that experiment, having that model set up can give you a world of predictive insight. Having external data sources, what are some market conditions? What happens if the ship doesn't come in? What if it's held in port? Assets that might get influenced by that sort of market factor, or regulatory or compliance data. So this is important to bring into our digital twin so that if we have something happening that's going against regulatory or compliance data or industry standards, that we get flagged about that, or it comes up so we don't have to chase a problem 3 months after we should have seen it. So let's talk about how we're going to get some of this data, right? And again, this is a very comfortable level, right? Probably a lot of people on this phone, right? On this webcast. And that's living about how we do things in design and engineering and architecture, right? A couple of things to make note of is that there's quite a few pieces of technology that work with the Autodesk data model, which doesn't require you to have Autodesk software, right? But there's a lot of things you can use through your existing technologies from Autodesk, such as advanced interoperability. So the image you see there in the middle with different sources coming from different modeling softwares, you're probably never going to just tell a company by pain of death, you must use this CAD software. You can't just uproot one thing from one company just to benefit your goals of a digital twin. What you have to basically do is live in the context of what's possible, right? So what's possible with Autodesk is bringing all these sources in. When the sources update from the, let's say, external source, they can automatically update in your source. This data can be fed into the construction cloud, to the data model, to the vault system, things like that, which you might be playing in that need to go into your digital twin at some point. But essentially, all this can be available to the data model. So the metadata comes in with these things. Classifications for Revit and OmniClass classifications can come in with these sort of things. Metadata, which is important to this. This has become something over the last 5 or 6 years that Autodesk has focused heavily on, is the interoperability and harmonizing your software platforms to be agnostic to other things. And that might seem like an oxymoron, but essentially they understand that you can't just have one thing in the world, right? Now, how you do your execution is also ultimately important. So for instance, that machine in the center there, is great for fabrication. It's probably got every nut and bolt and washer and bearing that I would ever need. But really, when it comes to a general arrangement or a space claim or different levels of submittals for the process, I don't need that detail. There's people in my digital twin execution plan that don't need that level of complexity, but they need the data. They need the metadata, they need description, they need space claim, they need material properties, perhaps, electrical properties. So having an end in mind for your CAD design becomes really important to this process. And there's technologies that also, again, even within the Autodesk ecosystem, work very closely with each other in this. So if I use an example of Inventor and Revit, like on the right-hand side, I can take Inventor data and have it have different levels of development of 100, 200, 300, 400, and 500, and have that passed information into Revit automatically as a Revit project, as Revit families, and some of the metadata actually will transfer today as well. And they're just increasingly enhancing that portfolio to make it much more connected. Okay? And that's actually shown with some of the things they've done with APS on the Autodesk platform services, such as manufacturer-informed design. This exists today for Inventor and Revit that helps pass information from manufacturers to architects and ultimately to the digital twin. So complex fabrication detail and drawings authored and published in Inventor become readily available to a Revit designer to spec into a design in a simplified format. You know, gone are these humongous step files that you just can't consume. You know, they're going to be actually, you know, data driven so that you can say, I need this staircase, I need this chiller, I need, you know, this hot water tank, whatever you want to have it. It could be a piece of equipment, right? But it's going to automatically have the level of development that you need for your Revit designs. It's not going to have that fabrication level. Now, once that designer says, yep, I want that, I tell the fabricator, there's a production engineer that will also help automate that documentation for what they sized inside of Revit. Because that Revit model uses the rules of Inventor. It's not just a static, you know, Revit family. It's actually a flexible staircase that has design criteria built into it, so the architect is enabled based on the rules of the fabricator to size and make things accordingly, right? So this is stuff that already exists today that has been rolled out on this you know, platform services. Now a little bit more about how we're going to get it. Okay, this is going to shift gears a little bit here and talk a little bit about simulation. Okay, so up to this point we talked about CAD models in that last slide, very important information. But now let's say we have CAD models, right? Let's say we've started putting things together, right? There's different ways you can view simulations. Typically, if you have completed 3D models and assemblies and arrangements of things, you typically can do descriptive hindsight, where you might look at a problem, you know, chart it into Excel and say, these are some data points that we saw, but it's nothing that's real time. Nothing's really coming to me out initially. So I can say what happened and start simulating what happened or analyzing what happened. It's very descriptive, right? Now we start looking at diagnostic. Okay, this is where your brain comes in, because a digital twin will never replace your brain. Okay, so essentially looking at the insight of why did it happen. You know, so here's the data points, we plotted them. Now diagnostically, you know, what's happened here, what's our insight about why these things occurred. When you start making the shift towards predictive, towards real-time simulation and actually running proper experiments, you can become more predictive. What if? What if I change this, I add another machine, I add another, let's say another loading dock open for bringing equipment in. Let's say I add another crane in the shipping yard, right? What happens if I do something? What's my what if, right? And then running your same experiment that you've already built through more predictive measures, right? So what might happen? What might occur, right? Now, after you figured out what might occur, how about we get prescriptive? You know, how do we, now that we have this problem, how do we make changes, right? Taking your robust digital model or general arrangement, your aggregation of data, and saying, how can we make it better? How can we plan for change? What happens if we increase our business by 20%? What is that going to do to the bottlenecks that we may occasionally see? Is that going to exacerbate the problem? Is that, what do we have to do to make the change before we're forced to? How can we keep reacting to the market in a positive manner and still maintain our relationships with clients and vendors and having a positive experience as we grow? So this is something to talk a little bit more in depth about that, right? So a lot of times you think about digital twins, a lot of people just think, will it fit, right? Is this going to fit through the door? Is this going to fit in my space on the floor, right? And how do I track changes around this? You can do this today with the factory design utilities, with Navisworks, with bringing data into Revit, aggregating your models and such, point cloud information. A lot of this speaks to the will it fit scenario. And for some people, this is a good enough digital twin. You may be doing a lot of this today as a descriptive twin. It says, this is what we have, this is where it is, these are clashes that we have, here's experiments that we ran on existing content, existing data, right? What happens if we move this? What happens if we do that, right? It gives you the information about will it fit. Nothing here tells you, though, about will it perform or how is it performing, right? So for that, we look towards simulation. What you have in a traditional like product design collection or in Revit is really that will it fit stuff, okay? So more burgeoning technology is discrete event simulation, which can also feed data streams to a digital twin, right? So now it's about how is it performing? What happens when I have all these people coming in? Where are they walking? Where is the machines going? What happens when there's failure? What happens when there's bad parts? What happens when someone calls in sick? What happens when we have to add another line? What happens if a fork truck breaks down, right? Give me the empirical data today in a perfect scenario, and then let me start making changes. Let me start being predictive and prescriptive about things we might run into. So how do you maintain the data, right? So I already talked about this at length, right? Data collection, integration, data storage, synchronization, version control, lifecycle management, creating feedback loops, interoperability and standards. These are all important to maintaining that digital information that comes to us. So using, again, IoT platforms such as AWS and Azure, using data analytic and simulation tools like FlexSim. Now, how do we help maintain the data, right? So over years, we've done quite a few things in our world around digital twins and how we keep things synchronized and up to date, right? Here at Imagine-It, we've created products like Clarity in our software utilities and Imagine-It Pulse, right? So Clarity is a great tool to make sure that things are staying fed to the digital twin. You're nourishing that information coming in an appropriate automated manner without increasing your man hours to create monotonous, mind-numbing tasks. So things with Clarity, you can automate a lot of things, right? Collaboration, data, synchronization of data, management, printing and exporting. How much time do you spend a day printing and exporting? We would love our digital twin to just accept these things automatically when things happen, when triggers happen, when events happen, when your digital twin execution plan says, this is the next step. Also connecting your data, not just sending it, right? That's what our Pulse system is for. So you can migrate or you can integrate. You can work where you need to, right? So one example is connecting many disparate project management systems like Procore and the Construction Cloud, and either migrating to it or integrating with it. Now, this is a cloud-based technology we work with APS on as well to connect many business systems, much like you see across the bottom below as an example or as a sample, okay? So we can connect these data streams together to help feed and nourish that digital twin. So there are some case studies and examples we want to touch on just briefly, and then we'll kind of dig into some more things here and wrap up our day. One example for platform services is, this is an example of I would say, a descriptive twin from automatic systems. With this particular example, it's a visual digital twin of a part of a conveyor, right? So someone can actually go and grab a barcode, launch this interface. They'll be interactively be able to select on things. It'll bring up material specs. It'll bring up part lists. It'll bring up reorder forms. It'll provide the information that someone would need as a maintenance engineer to maintenance this conveyor. But this can be anything in your digital twin world, right? So what's important about what they were approaching is this was what they want to view as a digital twin. Something where It gives someone the ability to see the product, to interact with what's going on, to see all the information readily in one space, and then dispatch service for replacement. Where this can go to become a higher level digital twin is we start applying sensor data that someone's alerted when something fails, or something gets out of alignment, or there's a lot of failures that are happening, or maybe there's a jam that packages or product builds up on this conveyor. And there's a fair amount of standardization that goes into digital twin data streams, making sure you're meeting a lot of these things, right? So ASME or ISO standards, Institute of Building Sciences, things of that nature, right? So National BIM standard. How do we make sure that these standards play into our digital twin execution plan? Well, you build the logic into your charter. Alan, do you want to speak a little bit about these next two slides?
For sure. Thank you, Mark. So the examples that we deal with on any given day regarding the Autodesk offerings for digital twin, obviously Tandem, as Mark alluded to and spoke to, all of these disparate, perhaps currently disparate systems, with the advent of digital twin and the connectivity of these tools, we have the ability to take all these disparate systems and again feed a given digital twin. And so as you can see here, no matter what it is you're trying to track, if you're in the Archibus environment, if you're tracking the equipment in that's coming from some controls data from Honeywell systems, what we need to observe is these various data points, and we need to have that system, a digital twin access point for all these data points. And that's where we have something like Tandem that, of course, as we've spoken of today, is fed by all of the various work that we in our given industries, no matter who you are, the architect, the engineer, the contractor, the manufacturer, the healthcare facilities manager, all of you play a role in consuming or creating the data that is housed within that digital twin.
All right. Thank you, Alan. So how you approach a digital twin plan methodology, right, is essentially a complex process, right? But it's not a CAD process. It's really a business process. And that also involves information technology. Anyone who approaches a digital twin purely from a CAD standpoint will just end up with a descriptive twin at the end. They want to end up with some of the more advanced things we talked about. Involving information technology and IT, deployment of these practices really becomes an important aspect of this. If you approach this as an IT project rather than just a CAD project, you'll have much higher success in a digital twin. And from our perspective, we've done a lot of things around building implementation plans for project phases, for functional development, what the information technology needs to look like, and what the deployment of any particular plan might look like as well. And we've done several digital twin transformation projects, as you see on the right-hand side there. It's just some examples. These are all things that help feed the overall charter of a digital twin. Some other things to consider is also, if you need assistance or if you approach things in a way for database management and creation and connecting these elements, development of that data strategy and data integrations, dashboards and ongoing maintenance of that dashboard or model analytics, as well as developing use cases, right? There is so much here in a digital twin, but what is our success? What is our use case? What is our end in mind? And then we work backwards from that goal, right? So different use cases will help define what our digital twin strategy would be with our clients. Typically, it's things around multiple technologies, whether the Autodesk or non-Autodesk technologies, but ultimately the goal for our clients is getting to the level of digital twin, which is important for you. So today in our webcast, we did examine digital twins and their scope. We've learned about industry challenges and key outcomes surrounding them. We explored a digital twin execution plan and things that make up things to consider as part of that plan. Ultimately, it's a very long conversation to get into the nitty-gritty of that, as we kind of alluded to here in the last couple slides. But we also understood what data is needed, how we need to aggregate it, ways we might maintain that data through Autodesk Platform Services and connecting disparate systems. And lastly, how Imagine has helped our customers reach some of their digital twin execution goals and that methodology. So at the end here, we'd like to thank you for attending today. We're going to end up stopping the recording and open up for some Q&A. But I'm going to leave this slide up because this will give you some real life examples you can jump to that we showed earlier today. So on the left-hand side is a scan to that design and make, the full report available on our website, the industrial construction digital twin example, and the engine digital twin example as well.